Hello, everyone, and welcome to today's webinar titled Going Beyond AMI, Houston's Holistic Approach to Building a Smart Utility Network. Today, we'll hear from experts from the City of Houston and Xylem about how Houston is going beyond the meter to solve a number of operational and planning challenges. I'm your host, Chris Thompson of Xylem. Today's agenda. In just a few minutes, I will introduce in depth our experts from the City of Houston and Xylem. Next, we'll define the Smart Utility Network and see how it is different from a traditional AMI system. And we'll use the acronym AMI to stand for Advanced Metering Infrastructure or Fixed-Base Network that reads meters. Third, we will learn more about Houston and the evolution of the city's network and discuss how the city is leveraging that network to perform broad pressure monitoring in addition to other applications. Fourth, we'll talk about how utilities like Houston are leveraging smart utility networks within a broader future digital roadmap. And finally, we'll conclude with a summary and also your questions and answers to those questions that you put in the chat window of the webinar module. First, I'll introduce today's webinar speakers, and we have a great panel to speak with you today. First, Matthew Thomas. Matthew Thomas is a utility professional with 40 years of professional experience. He currently serves as Assistant Director at Houston Public Works Customer Account Services, or CAS. CAS in Houston provides customer information, billing, credits and collections, and all meter-associated services to not only utility customers within the City of Houston, but also to wholesale water services to many of the nearby towns and utility districts that surround Houston. Prior to joining Houston Public Works, Matthew spent 22 years in leadership roles in electric utility operations, followed by 12 years of financial planning and analysis leadership in the oil and gas industry. Our next speaker is Bernadine Merrick. Bernadine is the Water Vertical Marketing Manager for Census, a Xylem brand for North America. Bernadine focuses on developing growth strategies through market intelligence, voice of customer, sales enablement, and industry relationship building. Bernadine has more than 20 years experience in industrial automation and control systems and equipment for a variety of industries, including oil and gas, pulp and paper, mining, and of course, municipal water. Bernadine holds a chemical engineering degree from Miami University in Ohio and an MBA from Carnegie Mellon University. Freddie Guerra, our next speaker, currently serves as Client Solutions Manager at Xylem. Freddie has over 30 years of experience collaborating with clients to optimize their water, wastewater, stormwater operations and assets. Prior to joining Xylem, Freddie was a regional sales director focused on optimizing assets and infrastructure using technology, IoT or Internet of Things, analytics, big data, and predictive maintenance. And finally, I am Chris Thompson. I currently serve as Director of Strategic Initiatives for Census, a Xylem brand. I support our sales team as we work to solve customer challenges across the water cycle. I have over 21 years of experience in the water and wastewater industry with progressive experience in consulting engineering, utility design, and solutions providing to utilities. I have a Master's of Science degree in Environmental Engineering from Johns Hopkins University in Baltimore, and I'm a registered professional engineer in North Carolina and Maryland. So, now that you've heard about us, we'd like to hear about you, the audience. Throughout the webinar today, we will have 4 poll questions where we ask you, the audience, to give us your feedback. Today's first poll question is this: How would you best describe your organization? Do you work for A, a utility, B, a consultant or consulting engineer, C, a solutions provider, D, a regulator like a state regulator, or E, other? I'll give you a few minutes to enter your vote into the panel that just popped up on your screen. This helps us gauge the audience and also the topics that we'll address throughout the seminar. So your vote is really interesting and intriguing for us to see so we can understand who the audience is. Again, A, utility, B, consultant, C, solutions provider, D, regulator, or E, other. All right, and the results are in. More than half of you, 52%, represent utilities. So that's great to hear. You'll hear in just a few minutes from Matthew Thomas, utility in the city of Houston, so you'll understand his story from a utility perspective. About a quarter of you, 24%, represent consultants. So thank you very much for joining us. Almost 20%, 18% are solutions providers. So thank you. 2% are regulators, so thank you for joining us, and the last 2% represent other parts of the industry. So thank you very much for the vote. That gives us a nice feel for who we're speaking with, and we'll move on now with the next presentation. So next, Bernadine Merrick-Xylem will take us through the history of water network technologies and help us by defining what we mean by a smart utility network. Bernadine, I'll give it to you to take it away.
Thank you, Chris. So I'm going to take you through the smart water network journey. And actually, it went as far back as 1870. And in 1870, around that time, there was a lot of urbanization, industrialization, and the utilities really saw that they needed to provide not only widespread water distribution, but also be able to account for it. So they saw this, they knew it was going to be a challenge. Even the Smithsonian had stated that between getting flow rates right within the pipelines, to velocity measurement, to pressure and positioning of the water, that they were in for a significant challenge. But they took it on, and they, from 1870 all the way to 1984, there was a lot of improvement as far as accuracy and robustness of the system. But then in 1984, there was a breakthrough with census with the touch read. But before that, think about it. Now, I'm going to have to admit that I'm one of those that remembers when the waterman and the meter man, you know, the meter man would be knocking on the door and they'd say, "Meter man," and then you'd open up and they'd go down in the basement. Hopefully you all admit to this too. And then they would read the measurement put it on a card along with all the other cards that they had collected. They'd then take those back to the billing office, and the billing representative would then take those values and enter them in a system. So you can see from all those little steps that there's definitely room for errors, and therefore there were some inaccuracies. So along came the touchpad, which allowed the meter man to meter person to actually touch a pad either near the basement or somewhere around the home with the meter data, and it would electronically go back into the office. So that cut out a lot of the errors, but you still had even in 1984, you had some limitations because it was based on the meter person's ability to walk that route, and therefore the frequency was limited. So in 1993, there was another breakthrough, and that was the radio read by census. And that allowed you to drive by and get the measurements. So In that case, the speed was greatly improved because now the meter person is no longer walking the route, they are driving the route. Although I should say there's still some that are still walking the route. Some utilities are still using some of the more, the previous uh, methods. So it hasn't gone away, but that has been the path forward. So then in 2006, the AMI, again, Advanced Metering Infrastructure, had a big breakthrough. It had more utilities adopting it, and it offered a way of having a fixed antenna, so it was fixed base. So no longer did you have to worry about the frequency, because before, you had someone driving by or walking by, you still had not as much frequency, but now you can have as many data points as you needed to get the information that you wanted. And what that did was increase the efficiency of the meter reading. It offered billing efficiency, and it improved the customer service. And let me give you an example of the improved customer service. So we have Colby. Ms. Colby is a director of customer relations for Water One in Kansas. And she said that really people they aren't fully grasping the impact of AMI. So let me give you more of what she said. She said, before you had sometimes 12 data points to address water issues with your customers. If they were collected on a monthly basis, that's 12 times a year. But now with the AMI, you can say Mr. Johnson has a question. Mr. Johnson, he wants to know why his water bill is so high. And she said, you can say, Mr. Johnson, on May 15th at 5 a.m., your water really spiked. And do you recall what happened there? And he thinks about it and he says, you know what? We finally fixed that pool. We decided to actually fill it in the morning when it was cool. And yeah, I do remember that. So what it does is it empowers customer service to better understand and respond to their customers. And it builds a credibility, with the customer, that you actually are able to understand what's going on with their water usage rates, and allows them to feel like it's a partnership. And she said that is a really powerful situation. It's almost transformative. So around 2018, AMI has been in for a while. There has been branched out as the network has gotten more sophisticated and AMI has gotten more adopted across the utilities. There has been an expansion, and actually Matthew is going to go through this in more detail, so I'm not going to steal all the thunder, but things like pressure management and temperature monitoring, remote control, which is really, really good to be able to turn off services, turn on services, throttle. And so it gives the utility more flexibility in the opportunity to respond to things like just climate change, which you have unplanned events. So that is really, really important. The other thing is the smart monitoring of other equipment that's on the network. If you look to your right, you'll see this valve that's being monitored for pressure, for temperature, for level. And so this is giving the utility a lot more insights than they originally had, and can expand to all parts of the water system. So let me recap all the benefits that I see that are some are tangible, some are intangible, but you have increased data accuracy, increased data frequency, broadening of applications and outcomes, increasing consumer engagement, which it's almost priceless if that is, and then a reduction in human effort and error. So let's look at some of the components that are part of the smart utility network. I'm not going to go through each piece of equipment, but in the general, you have the smart residential meters, you have the commercial and industrial meters, you have the smart gateway with third-party sensors, and then you have the base station or collector. And then you get into a lot of the top level that can give you even additional operational insights and customer insights, such as the network management software, the smart applications and data analytics. And the last, but definitely not the least, is the customer portal, so that they can get more information on what's going on with their usage. And that really does give them empower them. So I've sort of said this before, but there's the other things that are part of the network that are that offer a lot of benefit to the utility and the customer, such as the process pressure monitoring and the ability to increase the operational efficiency, as well as long-term capacity planning. The other thing that's really important is the ability to connect to other areas within the utility. Like I said, with any kind of unplanned event, this is crucial. Stormwater, flooding, wastewater, reclaimed water.
Well, thank you very much, Bernadine. Yeah,
okay.
Thank you very much, Bernadine, for taking us through the history and the evolution of what a smart utility network is. So you took us really from back in the day, as the kids would say, from 1870s to when metering was really just invented, metering this flow of water, which was a real technological challenge. And then we had a long period where and still, to your point, utilities are still, in many cases, doing manual reads or direct reads. And then we did have the transformation, the technological transformation to walk-by systems and then drive-by systems, and then fixed-base systems used just for metering, and now systems using that same network to do other things, going beyond the meter to do other things with their network. So that brings us to our second poll question, and you'll see the polling module that popped up. If you would, audience, take a few minutes to address this question. Where are you, if you're a utility, or if you're not a utility, if you're one of the consultants or regulators or solution providers on the call, where do you think most utilities are in the smart utility evolution that Bernadine described? Do you think most are still at that currently at that direct read, the manual reading and transcribing stage? Are they mainly in the AMR, that walk-by, drive-by mode that Bernadine talked about? Are they starting to move and think past that to entertain topic of AMI, that fixed-based advanced metering infrastructure network? Are they already on that path, either there or migrating to AMI? Or E, are you going beyond AMI and starting to think about other ways to apply this communication and sensing network to other applications within the utility? Or F is sort of a catch-all other answer. So if you would, A, B, C, D, E, or F for the answers here to give us an idea what your thoughts are. We'll give you a few minutes to enter those answers. And the polling should just be about finished. I see the poll is ended. All right, well, it looks like 40%, 2 out of 5 are either migrating or currently at a fixed-base system. So it sounds like many in our audience, or at least a plurality in our audience, are at that stage where they have an AMI network and might be thinking about using it for other applications. And that may have been what brought you here today to hear this conversation. About 30% are still evaluating AMI, so this might give you food for thought as to other business use cases and other ways that AMI could benefit. And Bernadine talked about the really transformational customer service aspect, which I found fascinating comment, that it really helps empower morale within a utility to have this information, this discrete information at your fingertips. A good mix after that, several folks still at the AMR or walk by, drive by stage. We do have 8% who are already thinking about going beyond AMI in terms of pressure monitoring, or how do I digest this data for things other than just water meter reading. And that's really what we wanted to spend our next few minutes talking about, is a utility like Houston that is really considered not just a solution for meter reading, but considered a solution for doing those beyond AMI things. And so with that segue, our next speaker is Matthew Thomas from the city of Houston. He's going to give us background on Houston Public Works, and also Matthew's going to walk us through the evolution of the city of Houston's smart utility network. And so with that introduction, Matt, I'm going to turn it over to you. Oh, Matt, I think you might still be on mute. So one of the pitfalls of our day in technology.
Okay, sorry about that.
No worries.
Hello, everyone. It's an honor to have the opportunity to participate in today's webinar. Before we begin our discussions, let me share a little about who we are and what we do. Houston Public Works is one of the largest and most diverse public works organization in the country. We're responsible for creating a strong foundation for Houston to thrive. We are responsible for 16,000 lane miles of street and drainage, production, distribution of over 146 billion gallons of water per year, collection and treatment of wastewater, permitting and regulation of public and private construction. We process over 5.8 million water bills per year, while also managing the customer service experience. We are responsible for maintaining approximately 500,000 meters and the supporting AMR, AMI networks and devices. The city of Houston was the first major city in the US to use automated meter reading technology for their in-ground water meters. Since then, we have shared our experiences with utilities all around the country. Following the initial implementation of AMR, Houston Public Works has followed a relatively standard progression relative to the use of AMR, AMI technology for meter reading. Today, we will review Houston Public Works' evolution from AMR to AMI and how we're leveraging the technology to enhance our smart city, smart utility capabilities. Historically, each functional department in a utility would adopt technology that suited their individual needs, and most often that approach produced one-trick ponies. In evaluating and selecting the appropriate AMI technology, Houston Public Works adopted a holistic approach. We decided that we would not invest millions of dollars in technology that only served one purpose. We required a system that would support other public works functions beyond meter reading. By following this approach, it allows us to leverage our investment and eliminate both technology and data silos. So the smart utility network. So for Houston Public Works, it is data communication built upon the traditional AMI solution and expands it to other applications and functions within the network coverage area. A smart utility network is positioned to monitor many spatially distributed devices, a comprehensive solution incorporating multiple types of devices, communications, data, and data intelligence. A smart utility network, it leverages your network to solve other utility issues. It takes advantage of battery-powered radios and sensors to communicate back, for non-traditional sources. it is tangible, and it's adaptable. One of the key things about a network system is that in this particular case, it's not SCADA. It's not intended to replace SCADA, but to supplement SCADA. And by utilizing both electrical powered and battery powered devices, it provides the highest level of flexibility. The evolution of battery technology is quickly changing the landscape in utilities. Battery-powered devices are very cost-effective and can easily be deployed in remote and challenging locations, where electrical power is both unsafe or cost-prohibitive. Also, working with battery-powered devices does not require the equipment, training, certification, and experience required to maintain electrical devices. Network coverage. This was a key area for us. So with Houston Public Works and adopting a holistic approach, several things were critical in the development and installation of our network. And so I referenced this as Houston Public Works and not our Customer Account Services Organization, again, because we looked at this from an entire public works standpoint and how this network could be utilized. There are two primary areas when you look at networks. Most of us think about broadband, but Public Works, we looked at kind of a two-stage prong. One would be the systems that require broadband access versus systems that do not require broadband support and their low data usage. And so those are another opportunity to leverage and not try to place everything across broadband. So the approach we took, again, when we talked about it being holistic, well, the first thing that we looked at was the design of the network had to be robust. It had to support our future needs, not just for meter reading, but for the functionality and capacity to support other functional areas. Areas like wastewater, water system operations, or stormwater and water quality. The second thing that we wanted out of our system, that it needed to be resilient / redundant. So we required in the design phase that in most instances that we would have triple redundant, at least 70% of our network would have triple redundancy, and everywhere else that we would have double redundancy. The third thing we looked at, we recognized that we would not fully and effectively utilize the system. So we built out the entire network from the very beginning. Again, we realized that we would not be able to deploy over 500,000 devices for meter reading in a short period of time. So it could be, 5 to 10 years before the network could be fully utilized. And that would be a waste of resources. But by making the network immediately available, we could programmatically change out our devices, but it also gave us the ability to be able to change out devices on failure wherever they occurred. And then additionally, it allowed the other functional groups within our public works group to utilize those assets fully more quickly because they have fewer devices within their operational areas. And then the fourth consideration for us about choosing the appropriate network really came around the fact that what is our core competency? And our core competency is not managing networks. So one of the big deciding factors was both the ease of operation and maintenance of the system. Flow and pressure was one of the most immediate opportunities for us to add intelligence to our utility. By leveraging AMI technology, Houston Public Works will have the operational intelligence around water loss management with timely and usable data. We'll be able to capture more revenue by identifying leaks and potential losses down to the individual customer. We will be able to provide near real-time data, alarms, and other information to better manage our system. We will be able to proactively address system problems and often before the customer is even aware that the problem exists. And it will enable us to improve our regulatory compliance. One of the big things that we're doing is by implementing district metering areas, we will be gaining visibility and intelligence of both flow and pressure data to understand what is happening, not just on our mains, but down to the neighborhood level. By utilizing a combination of both pressure sensing devices, the Ally water meter, which gives us both pressure and flow. Again, we will be able to go down to a neighborhood level and know exactly what's happening in those areas. By utilizing intelligent dashboard applications connected to those devices, we can identify critical changes in our system's operation. By being able to quickly identify conditions, the kind of conditions that could, in some instances, lead to transient water pressure or other compliance issues where, again, we may have low pressure could lead to boil water notices. By us having faster visibility of those potential areas, we can react more quickly to solve those problems. By taking advantage of emerging technology, it gives us the information we need to operate more efficiently, extending the life of critical equipment at all of our pumping and lift stations. To become a truly smart water utility, Houston Public Works is finalizing its 5-year roadmap that will bring continuity to our adoption of new technologies. We want to leverage our investment in AMI, but we want to be device agnostic so that we can take advantage of the most effective technology available. We will ensure continuity by utilizing a common connectivity platform, and more importantly, a common platform for our data. By adopting a holistic approach, we will ensure that any device or technology we adopt will share data so that we can reap the full benefits of big data and big analytics.
All right. Well, Matthew, thank you very much for taking us through Houston's thought process and goals as you entered into this phase of your evolution. So thank you very much for going through that detail. Our third poll question builds on what Matthew was just describing. You heard what Houston was looking for in terms of wanting to do things revolving around pressure monitoring and pressure management. Also, a real key is sharing data. You know, in our industry, we hear all the time about silos of data. So a real key, I know, with the city and many cities is data sharing. So is that a key consideration? So besides metering and billing, to get to the question, what utility network application do you find most intriguing? That pressure monitoring or management, that data sharing that I mentioned, increasing operational efficiencies, maybe being more proactive with operations. Maybe it's long-term capacity planning. Are we interested in long-term volume and pressure availability, or is it E, other? So besides metering and building, what application do you find, the audience find most intriguing? A, pressure monitoring and management. B, data sharing. C, increasing operational efficiencies. D, long-term capacity planning. Or E, something else. And we could also talk about the something else if it is in the Q&A. So I'll give you a couple more minutes. Yes, sir.
Hey, Chris, where's the all of the above?
Oh, that's true. Yeah, maybe that's a good point. Maybe we need an all of the above button. That would be a good tweak, Matthew. All right, so you all have just a few more seconds. Looks like the poll is just ending. Let's see how we're doing. But to your point, Matthew, we do find utilities. It is a big investment. Network is a big investment. It's a 20-year investment, and so as folks learn about the capabilities of these networks, you do get more and more applications, and that's one of the exciting things. Utilities bring us a lot of times the application and the uses. Okay, so the poll questions, pressure monitoring and management is 35%. That comes in first place, at least among these answers. So folks see a lot of capabilities, a lot of functionality in being able to monitor distribution pressure and then manage it, either for customer service or maybe for reducing non-revenue water. C came in second, increasing water system operational efficiencies. So being more proactive, being sharper, I guess, with our time and our folks' time and energies. And then in third place, data sharing with 16% data sharing with other departments and even other partners, whether they be utility partners or vendor partners, consulting partners for sure. And then long-term capacity and other are some other considerations that you all voted on. So thank you very much for the third poll response. And Matthew, again, thank you for taking us through City of Houston and your journey. So, and that brings us to our final speaker for today. Our next speaker is Freddie Guerra. Freddie Guerra, a Client Solutions Manager with Xylem. Freddie is going to talk about Houston's holistic approach, an approach being adopted by many utilities that we interact with, I know, and talk with. And it's really a road mapping that positions the smart utility network in the context of that long-term digital roadmap. So Freddie, with that, I'm going to turn things over to you.
Thank you, Chris. Good morning and good afternoon to everyone. As the City of Houston continues its evolution to a smart utility network, this journey requires an overarching vision of the future state and a roadmap to unlock the full range of benefits. The future state will enable the city's ability to understand what is happening in its system in near real time, such as pressure, flow, also what is happening in what may happen in its system, again, predicting potential leaks and pipe burst, and then what to do when something does happen, like diverting flows. While each of these capabilities can save money and increase efficiency, their true value lies in what they represent together. It's really about a new way of understanding the utility and a new way of running it. This future state is achieved by creating a smart utility network, which we've discussed in the previous sections, that leverages a fully connected system. This empowers the city to make decisions on data-driven, risk-informed insights to manage assets in near real time. So what's the difference between digital asset management and traditional asset management? Digital asset management pivots away from traditional AM that focuses heavily on historical standards, CapEx cost, and reactive behaviors. Digital asset management allows organizations to look at the bigger picture, focusing on assets that include people and technology, and leveraging enablers like real-time data rather than static snapshots of historical data alone to optimize performance and inform data-driven decisions. Digital asset management begins with connecting the physical world to the digital world. It's about generating data from smart meters, pressures, and temperature sensors, and other devices, and then transmitting this information, this data via communication network. Ultimately, this allows the organization to combine that data into a central location for processing, such as a data lake, and then using data and analytics to create integrated real-time dashboards to inform decisions. Afterwards, utilities and organizations can begin leveraging machine learning to analyze current and historical data to predict future conditions and events. Finally, using all this together, the dashboards, the insight, the predictions for data-driven, risk-informed decisions and actions, it's about going back from the digital world back into the physical world in creating action with these insights. By embracing this approach, an enterprise or organization will create digital threads, which is denoted by that blue circle that's being animated. This allows utilities and organizations to share data, information, and insights throughout the entire enterprise, really taking action from one source of truth. And by doing so, you're placing the power of technology in everybody's hand across the entire enterprise. So as Matt mentioned, their evolution and future is being guided by a roadmap. As you look at this roadmap, your digital journey may take a different approach, and it doesn't have to be sequential. But like the city of Houston, there are going to be many different stakeholders with varying needs. This roadmap provides the flexibility to address those needs. And I'm just going to go through 4 of these needs. They're basically, required by different departments or divisions within the utility. The first is focused on apparent losses and real losses. Using digital tools to understand underperforming meters, also to identify probability of failure, consequence of failure for pipe segments, and then leveraging that information through a connected system for a holistic non-revenue program. The other is identifying and mitigating risk. So by using this roadmap, you can understand where your risks are and then implement strategic interventions like condition assessments or placing strategic sensors throughout the distribution system for transient monitoring and more. The other is improving level of service and optimizing performance. So as Matt has identified in his section, you identify your priorities, whether it's pressure, leaks, water quality, or flow, and then you leverage the deployment of these smart devices and digital solutions that allow you to share this data and insight to really optimize the performance of your utility. And then the last flexibility that this roadmap provides is using that real-time insights to drive data-driven decisions. So by using the proliferation of sensors, communication technologies, computing, and digital threads, you can assist emergency preparedness. For example, moving away from being reactive as problems arise and start predicting and addressing those prior to them occurring. The other is assisting with operation maintenance by leveraging digital twins to boost operational efficiencies, save cost, increase reliability, and enhance safety. And then the last one is really focused on planning. A lot of organizations, both in the public and private sector, are now scanning the environment, collecting, analyzing, and clustering indicators that challenge some of the strategic assumptions, as well as identifying threats and opportunities to prioritize some of the capital investments. So in closing, many of these organizations are finding that their past technology choices have limited their strategic options and business agility. So enterprises are now ensuring that the overall business strategy is supported by clearly aligned technology choices, which is really represented by this roadmap. And then also, this is especially important for those utilities and organizations that are beginning to evaluate AMI. Going beyond just meter reading and billing, what else can that system do for you? Matt, did you want to add anything else into this slide?
Yeah, you touched on each one of those areas, and I'll maybe just try to add a few other comments. When we were talking about the water loss part of that, one of the things that having this new technology and emerging technology allows us to be able to do is to now become proactive in dealing with those water leaks, not just from the benefit of our side, but from the benefit of our customers, so that instead of a customer being figuring out 2 or 3 months later that they've had a water leak, we can within days identify leaks and notify the customer proactively that they have a leak in their home that could potentially affect their water bill, and allow them the opportunity to be able to save cost and expense for themselves in addition to us saving lost water, which is ultimately very important for us. Because it's a scarce resource and getting scarcer all of the time. And then each one of these functional areas, the great opportunity that exists there, again, pressure and flow, knowing exactly what's happening in your system where is critical. Wastewater management, knowing what's happening with your lift stations and even at your manhole covers, knowing where there's flooding, overflow in those situations are critical. But more of that becomes increasingly critical is pulling all that data together to be able to understand what's happening with your system. You know, particularly if you look at what we go through here in our area, it's either hurricanes or you know, which produce flooding. We have power outages. And so one of the lessons we've learned, even just most recently, from Ice Storm Uri back in the February timeframe. Nobody expected that to be anything more than a cold weather event and for there to be pipes burst and leaks. But one of the things that was not as anticipated was that it would actually affect our power supply. And so that caught a lot of folks by surprise. And so we learned from our various weather events that we can't always rely on simply SCADA. So now having battery powered devices as backup to SCADA, so when power is not available, and you can't put generators everywhere. We have 465 plus lift stations across the city of Houston, and having generator power at all of those locations, and even being able to ensure that the generator will come on and work is not always for certain. So having even backup systems to some of the devices that are SCADA. But there are opportunities like in the pressure area where that doesn't exist, and now the battery powered devices gives us intelligence. And instead of in a critical crisis mode, having to scramble around getting data from various groups, you can have a dashboard that gives you a view of every part of your operation and what's happening in those specific areas. Now you more effectively communicate with the public about what's happening and what they can anticipate. And in floodwater area, even those critical areas that they need to avoid and potentially save lives.
All right. Well, Matthew, thank you for that additional color to the roadmap discussion. And Freddie, thank you for taking us through the idea of a roadmap guiding all the selection of new technologies. Speaking of new technologies, that brings us to our final poll question. What do you think is the biggest barrier to utilities adopting new technologies? Is it A, procurement processes, B, internal change management to the utility, C, community acceptance to new technology, D, financial challenges, or E, other? And no, we do not have an all of the above button on this one either, Matthew. We just have those 5 selections. Is it A, procurement, processes, regulations, B, change management, C, community acceptance, D, financial, or E, other? Give you some time to answer that question. It's always an interesting question when you do talk about the number of benefits of a system, these systems. What is holding folks back from partaking? All right, so the poll is ended. And let's see how we are. And Larry, I see. Thank you. The answers. I think we were tweaking the answers at the 11th hour. So I apologize for the slides not exactly match up with the polling. So still, I think we can glean some things out of the poll. So financial is a big piece that folks have identified in the discussion. change management or change leadership sounds like it's also a hurdle as the utilities are embarking on new technologies. So thank you for the poll. Apologize for the text, the typos, or the tweaking of the text, but I think we do get a sense that certainly there's some financial concerns as utilities embark, but also there's going to be some human factor, and I think we see that in everything we do, a human factor of overcoming a fear of change or concern about change. So thank you for the feedback there. So that brings us to today's summary. We still have a few minutes for questions. So in summary, smart utility networks are, as we heard, are the latest in a long process of improving data collection from water utility networks and also in terms of utility operations. Today, the networks provide the core functions of advanced metering infrastructure, or AMI, but as we heard today, utilities are already or seeking to go beyond just metering with these networks to be able to monitor things like pressure and mitigate those pressures, to be able to remotely control services and all the things that Matthew described in his talk, and that was a consideration for the City of Houston. So we also learned today about how City of Houston is on the cutting edge of this technology and has been really on the cutting edge of technologies. The city is looking to their smart utility network to help in a number of non-traditional metering applications, such as pressure management and using that data for operational intelligence, but also long-term planning intelligence. The City of Houston provides water to most of the surrounding communities. Matthew touched on that, the partners that CAS and the City of Houston work with. And so really, in partnership with those utilities, the city is now providing this data to those participating partners. So really, this network is becoming a regional resource as well as just a municipal resource for smarter water and smarter water operations. And then finally, we heard that the smart utility network really provides a keystone, not only for Houston, but for other cities as they embark on new technological procurements and new technological roadmaps. It really is the keystone to that roadmap, so that as we move the future away from just metering and billing to other applications, this is a real key, a real foundation to help manage those assets digitally across the water cycle. So with that, thank you very much for your attention. We now have, it looks like about 6 or 7 minutes for question and answer. And so thank you for those who have been inputting questions into the chat, some interesting questions. So let me ask our panelists to unmute themselves. So we'll bring Matthew and Bernadine and Freddie back to the conversation. And the first question that came through was related to hurricanes, Matthew. And the question was, how's your network fared with hurricanes, and is the system backwards compatible? And I know the network is very new for you all, so I don't know if you had the misfortune of having a hurricane, but I did hear you talk a lot about redundancy. Maybe you could talk about how the weather and past history has impacted your selection and use of the network.
Yeah, well, just a little history. Hurricane Harvey, of course, was a major event that affected us in other areas, but the resiliency of the system was really outstanding. We had basically within 5 days after the water receded, 90% of our devices were back up and reporting across the network. And of course, that was our partial network, an older system, but even that low-powered system was resilient and was back up running within 5 days, again, of the water receding. So we've had a very, very positive experience with the resiliency of our systems. They have been reliable so that we've survived all major events. And by having backup power at our fire stations where most of our base stations are located, we've been able to stay up and running.
Matthew, could you talk about, follow up on that, could you talk about the importance of redundancy to you all as you were working to design the new system?
Well, again, that was the critical aspect of it, was Again, having the ability that if one of our stations went out, that we wouldn't be able to get customer information from the devices in that location. We wanted to be able to have failovers for each location so that, again, I could have two towers go out and that third location could still carry the data for that coverage area. And so 70% of our coverage is triple redundancy. And then the rest of it, have at least double redundancy more along the outside borders of our coverage. But that was critical.
Mm-hmm. Gotcha. Thank you. And I'll address the second part of that question. Is the system backwards compatible for reading if necessary? And the answer to that is yes. That the smart port radios can be read by the fixed-base system. They can also be read seamlessly by a walk-by, drive-by system. So in the event of a major issue where you lost a tower or several towers, the system could still be read through a walk-by, drive-by collector. So just to note that. And I will say this, I know it's been a tough week for utilities, especially in the Mid-South, as we talk about storms. And so, I just want to say, as we talk about backups, and just our hearts and our thoughts are with the folks in Western Kentucky, Western Tennessee, Arkansas, Illinois, and other states. I know I'm going to leave some out, but I know it's a tremendous tragedy there. So I just wanted to say that our thoughts and prayers are with those folks as well, as we're talking about storms and disasters. So, I'm sorry, Matthew.
Just wanted to add one other thing about that was a critical component in our decision-making process, is that we had to have the mobile solution as a backup. We could not go with a 100% reliance on the network. Again, given all of the different challenges weather-wise, we needed a component that if it wiped out, all of our towers, that we had some way of still being able to go about and get those meter reads and to utilize the system in other ways. And so that was a critical part of the decision process.
Okay, thank you, Matthew. Let me just say we've got just 2 more minutes. We will address these questions offline if we don't get to your questions. So thank you all for the questions as they came in. There are several that Liam has posted here, Matthew, and he says probably best for you. Talk about how the data is being used in the city. Are you looking at this to, say, calibrate water models long term, and what is it like in terms of the capacity planning aspect?
Sure. So it's all of the above. We are now building a ESRI based graphical interface where we'll have both our system overlaid with flow data, with pressure data, that will actually even have lift station operation data with overflow data from our manholes. Again, having a complete picture of what's happening with our system. It'll do 2 things. It helps us with planning where we may be able to recognize capacity issues without a doubt. But again, in emergency information situations, having all of your data readily available to be able to assess where your critical areas within your city are is just vital. But that's going to be ESRI Basin. We're now working with Xylem to use that as our data lake. Instead of having these individual data silos, all data will funnel into this one source where the data can be shared and modeled however needed.
All right, thank you. And I see we're at the top of the hour, so with that, again, we'll address those questions. I'd really like to thank our panelists, Matthew, Bernadine, Freddie. I'd really like to thank the audience and also WEF, our partner, for the opportunity to present to you today. And Regina, I'm going to turn things back over to you for some closing logistics.
Sure, absolutely. This was great. This actually concludes today's eShowcase. Thank you all for attending. The recording will be available at webfiresguide.wef.org, and we will send all registrants an email tomorrow with that link. And please visit our event calendar to sign up for future webcasts.